Hey guys, tonight we begin with a journey far back in time, nearly 541 million years ago, to a period when life on Earth was transforming in ways so profound it forever reshaped the planet. Tonight, we explore the Cambrian Explosion, a remarkable chapter in Earth's history when life, as we know it, began to bloom in spectacular diversity. Imagine oceans filled with strange, shimmering creatures, coral-like reefs forming, and the world gradually awakening in complexity. Before we settle in and begin our peaceful journey, take a moment to like this video and subscribe, only if what I share here truly resonates with you. Your support helps me create more of these videos, and if you feel like it, let me know where you're tuning in from and what time it is. It's always fascinating to see the many corners of the world where we connect. Now, dim the lights, make yourself comfortable, and let's ease into tonight's journey together as we explore what lies ahead. Chapter 1. A World Awakens. Setting the stage for the Cambrian Explosion. As we close our eyes and drift gently back through the eons, picture a world quite unlike the one we inhabit today. The Cambrian period, emerging after the quiet stretches of the Precambrian, marks a profound awakening of life on Earth. The continents were still fragmented, drifting slowly across a warmer planet with seas that stretched vast and shallow across the land, tinted in soft blues and greens under a sun that shone without interruption. These oceans, calm in some areas, subtly stirred in others by gentle currents, were a cradle for life, yet almost entirely unfamiliar to our modern eyes. For millions of years, life had been largely simple. Single-celled organisms floating in the water, some forming colonies, others drifting aimlessly under the slow rhythms of Earth's early days. Then, in a remarkable and relatively short burst of evolutionary innovation, life began to experiment with form, motion, and interaction in ways previously unseen. Imagine, in the dim underwater light, the first soft-bodied creatures gliding and crawling along the ocean floor, their movements subtle yet purposeful, almost like a quiet choreography beneath the waves. Some of them would grow protective shells or develop tiny appendages, intricate designs that would one day evolve into the complex bodies of arthropods, mollusks, and many other creatures we now recognize. Life was learning to move, to hunt, and to adapt, creating patterns and ecosystems that would ripple across the seas for millions of years. From a scientific perspective, the Cambrian Explosion is not just a tale of new species. It's a story of environmental and genetic factors converging. Rising oxygen levels in the oceans allowed animals to grow larger and more complex. Genes that controlled body plans began to diversify, enabling organisms to experiment with limbs, eyes, and protective shells. This slow, almost imperceptible dance of molecules and cells laid the foundation for ecosystems that would become incredibly rich, colourful, and diverse. As you imagine this ancient ocean world, notice the subtle hues of the seafloor, gentle sandy plains interrupted by early reef structures formed by microbial mats and early animals building their homes. A soft current moves past, carrying the faint shimmer of tiny organisms, each contributing to the invisible rhythm of life beneath the waves. You might even imagine the distant muted shadows of predators gliding over the seabed, and the quiet, purposeful motion of grazers exploring this rich new habitat. In this calm moment, take a deep breath and visualize the birth of complexity, the emergence of motion, and the first hints of the intricate dance of life that would eventually lead to the world we inhabit today. Life was beginning to tell a new story, a story of growth, adaptation, and endless potential. Chapter 2. Life in Motion. The strange and mesmerizing creatures of the Cambrian seas. As we continue our gentle journey back in time, let your mind glide over the shallow sunlit oceans of the Cambrian period. Imagine the water, clear yet tinged with a soft greenish-blue glow, moving in slow rhythmic waves. Tiny currents ripple across the sand-covered seabed, carrying with them the delicate scent of minerals and the faint shimmer of microscopic plankton drifting lazily in the light. The ocean was alive with movement, though it might have seemed quiet to an outside observer. Slowly, subtle shapes began to stir along the seafloor. The Cambrian seas were filled with creatures so unusual, so unlike anything we see today, that they almost seem as if they belong in a dream. Consider the trilobites, some of the earliest arthropods, their segmented shells glinting softly under the filtered light. They moved with a slow, purposeful grace, exploring the seabed in search of tiny particles of food. Their eyes, complex and compound, reflected faint glimmers like tiny jewels, scanning their surroundings with astonishing acuity. In this tranquil moment, notice their intricate movements, the gentle swaying of their many legs as they navigated the uneven ocean floor. Nearby, soft-bodied creatures like the enigmatic opabinia drift gracefully. Its unusual 5 eyes rotated independently, scanning the world with cautious curiosity, while a flexible, tubular appendage reached out to explore the sediment. Imagine the gentle waving of this appendage, a delicate dance of survival, as it searched for microscopic meals hidden beneath the sand. These creatures, while strange to us now, were pioneers of adaptation, exploring the possibilities of form and function in a world teeming with potential. Floating above them, translucent jelly-like beings drifted like clouds, their slow pulsations creating a calming rhythmic motion in the water. These early cnidarians and comb jellies added a serene, almost hypnotic beauty to the seascape, their soft colours reflecting in the rippling sunlight. They seemed weightless, suspended in the water, moving with an effortless grace that invites quiet observation and reflection. Amidst this diversity, some early predators began to roam, hinting at the complex dynamics of food chains that were beginning to form. The famous Anomalocaris, an elongated predator with spiny appendages and a circular mouth, glided through the water with a hypnotic, undulating motion. Though formidable, its movements were fluid and mesmerizing, a gentle reminder that even predators in the Cambrian Ocean moved with elegance and purpose rather than chaos. Reefs, not yet coral in the modern sense, but composed of microbial mats and the secretions of early animals, rose like underwater gardens. These structures provided shelter and surfaces for feeding, creating microhabitats that encouraged even greater diversity. Imagine gliding slowly over these reefs, noticing small creatures weaving through the nooks and crannies, their forms flickering in and out of view as they explore, feed, and hide. The beauty of the Cambrian seas lies not only in the diversity of creatures, but in the subtle interactions between them. Soft-bodied grazers gently scrape microbial mats from rocks, while others drift in the water column, filtering nutrients from the currents. The dance of life is slow, deliberate, and harmonious, an intricate ecosystem balancing movement, growth, and survival. From a scientific perspective, this period represents a remarkable burst of evolutionary creativity. The Cambrian Explosion was fueled by higher oxygen levels, genetic innovations, and ecological interactions that allowed species to experiment with new body plans, feeding strategies, and modes of movement. These early innovations set the stage for the vast complexity of life that would continue to evolve for hundreds of millions of years. As you imagine this tranquil underwater world, notice the soft light filtering down through the water, casting gentle patterns on the seabed. Visualize the slow, purposeful movement of creatures of all shapes and sizes, each contributing to the quiet rhythm of life. Listen to the imagined soundscape, the faint bubbling of currents, the subtle scraping of limbs against sand, the distant gliding of predators, creating a calming, immersive meditation on the earliest ecosystems of our planet. In this serene environment, life is both fragile and resilient. Every movement, no matter how small, is part of a delicate balance, a reminder of the intricate connections that sustain ecosystems even in the earliest chapters of Earth's history. Let yourself drift in this vision, noticing the complexity, the harmony, and the quiet magic of a world where life is learning to move, to interact, and to flourish. Chapter 3: Oceans, Continents, and the Breath of a Changing World. As we continue our tranquil journey, imagine drifting above the Cambrian oceans, feeling the subtle sway of the waters beneath you. Life is moving below, as we discovered in the previous chapter, but now let us take a broader view of the world, the stage upon which this remarkable evolutionary story unfolded. The Cambrian period, beginning roughly 541 million years ago, was a time when the Earth's surface looked profoundly different from today. The continents were fragmented, scattered like puzzle pieces across a vast warmer planet. Many landmasses were low-lying, and the shallow seas spread expansively over what would one day become dry land. These eperic seas, shallow, sunlit waters, created ideal conditions for life to explore new forms and interactions. Picture the gentle ripple of waves across these vast stretches of shallow water, sunlight dancing on the surface, reflecting soft patterns onto the sandy ocean floor. Temperature played a subtle but crucial role. Unlike today's highly varied climate zones, the Cambrian Earth was generally warmer and more stable. Ice caps were either minimal or absent, meaning that large portions of the planet were covered by warm oceans that supported the delicate chemistry needed for life to thrive. The steady warmth encouraged chemical reactions in the water, allowing nutrients to circulate slowly but reliably. As you imagine this, feel the calm warmth, the sense of continuity and balance that pervades these ancient seas. Oxygen, often overlooked in our modern experience, was a silent, invisible force driving evolutionary innovation. Prior to the Cambrian, oxygen levels were lower, limiting the size and complexity of early organisms. But in these waters, oxygen began to accumulate in meaningful amounts, fueling larger bodies, more active movement, and the beginnings of predation. Imagine the invisible presence of this life-giving element permeating every corner of the ocean, allowing animals to explore new possibilities for movement, structure, and behavior. Sediments on the seafloor tell their own quiet story. Fine sands and silts slowly settled, forming soft layers over which early life crawled and burrowed. These sediments were both obstacle and opportunity, providing a substrate for filter feeders to extract nutrients, for grazers to scrape microbial mats, and for the very first burrowers to leave their marks, small tunnels and impressions that would become the fossil record we study today. In your mind's eye, glide gently over these subtle textures, sensing the history embedded in each grain of sand. Currents too shaped the Cambrian world in ways both subtle and profound. Ocean currents distributed nutrients, carried larvae, and created gentle swirls that guided plankton through life-sustaining pathways. Imagine drifting in one of these currents, feeling its cool, steady push, the rhythm of water gently guiding the delicate balance of life below. And above it all, the sky cast its pale blue light over the seas. Sunlight penetrated these shallow waters, providing energy not only for early photosynthetic organisms, but for the entire ecosystem dependent on their productivity. Each flicker of light across the water's surface mirrored the quiet yet steady pulse of life unfolding beneath, a world full of potential unfolding in slow, deliberate motion. Geological processes quietly shaped the landscape too. Undersea volcanic activity introduced minerals that enriched the oceans, subtly altering the chemistry of the water. Tectonic shifts moved continents, creating new coastlines and shallow marine environments that encouraged diversification. This constant, gentle reshaping of the Earth provided life with new opportunities to experiment, explore, and adapt. Even the chemistry of seawater itself played a role in the Cambrian Explosion. Elements like calcium and silica allowed for the formation of protective shells and hard parts, giving rise to creatures that could move with more confidence, seek shelter, and interact in increasingly complex ways. Imagine the invisible dance of these elements in the water, joining with life in a slow, elegant choreography that would shape the very anatomy of the earliest animals. As you visualize these ancient oceans, continents, and skies, notice the harmony of forces: temperature, oxygen, minerals, sunlight, and currents, all working together quietly, patiently, to nurture life. This is a world in which even the smallest movement matters, where each ripple and current contributes to the rhythm of evolution. Let yourself drift with this vision, feeling the calming embrace of a planet awakening in complexity and potential. The Cambrian world was not chaotic but deliberate, a slow symphony of environmental conditions creating space for life to experiment, expand, and flourish. From the gentle sway of shallow seas to the steady warmth of a stable climate, every element of this environment contributed to the calm yet profound unfolding of life's earliest experiments and complexity. Chapter 4: The Blueprint of Life: Origins of Body Plans and Genetic Innovation. As we drift deeper into the Cambrian seas, imagine life experimenting in ways never seen before. Beneath the calm surface, evolution was quietly, yet profoundly, rewriting the rules of existence. The Cambrian Explosion was not simply about the appearance of new creatures. It was about the emergence of entirely new ways of building life. To understand this, we must explore the origins of animal body plans and the subtle, powerful genetic innovations that allowed them to flourish. Imagine a single-celled organism floating effortlessly in the gentle currents of the ancient oceans. For millions of years, life existed in simple forms, tiny single-celled beings, or slightly more complex colonies of cells. Then, in a slow, almost imperceptible dance of DNA, new possibilities emerged. Certain genes began to control the layout of an organism's body. These were the ancestors of the Hox genes, remarkable sequences of DNA that act as master architects of anatomy. With the introduction of these genetic instructions, life could now experiment with segments, symmetry, limbs, and body structures in ways never before possible. Picture a small, soft-bodied creature on the ocean floor. With a slight shift in genetic expression, it grows a segmented body, giving it the ability to move its limbs independently. Tiny appendages form, perhaps for feeding or sensing the environment. In this subtle, almost magical way, life was learning to build itself differently, exploring shapes and functions, testing what worked and discarding what did not. These genetic innovations were not rushed. They unfolded gradually over millions of years, yet the impact was monumental. Creatures developed radial symmetry, like the early star-shaped forms, allowing them to interact with their environment in new ways. Others developed bilateral symmetry, creating distinct front and back ends, which allowed purposeful movement, hunting, and escape from predators. Imagine gliding above these creatures, noticing their delicate movements, each a new experiment in survival and adaptability. The introduction of hard parts like shells, spines, and exoskeletons was another profound change. In the same way that an artist adds structure to a sculpture, early organisms developed mineralized structures for protection, support, and sensory functions. Trilobites, with their segmented exoskeletons, exemplify this innovation. Their hard shells glint softly in the light of the Cambrian seas, reflecting not only sunlight, but the evolutionary ingenuity that enabled life to expand into new ecological niches. Soft-bodied creatures continued to exist alongside these early pioneers of hard parts, creating a rich tapestry of life. Imagine a seafloor filled with diversity, spongy filter feeders rooted in place, gliding predators exploring every nook, and grazers quietly scraping microbial mats. Each organism represents a unique solution to survival, guided by genetic innovations that allowed them to shape and reshape their bodies over generations. Environmental pressures complemented these genetic shifts. Oxygen-rich waters allowed larger bodies to function efficiently. Predation, emerging subtly but persistently, encouraged rapid innovation. Every new feature, a sharper spine, a more flexible limb, a better eye, was tested in the natural laboratory of the Cambrian oceans. Imagine the gentle rhythm of this trial and error, each movement of a creature guided by the push and pull of survival, yet part of a calm, natural process unfolding over eons. One of the most mesmerizing aspects of this period is the diversity of body plans that emerged. Creatures experimented with limbs, antennae, shells, and sensory organs in an almost playful manner, as if the ocean itself encouraged life to explore endless possibilities. Some developed circular mouths with teeth-like structures, others evolved delicate tentacles or segmented limbs. The seas were alive with experimentation, a silent symphony of biological creativity, guided by the subtle hand of genetics and environmental influence. Consider, too, the origins of eyes, an innovation that would change life forever. Simple, light-sensitive cells appeared first, allowing creatures to sense light and shadow. Gradually, more complex eyes evolved, giving organisms the ability to detect movement, locate prey, and avoid predators. Imagine the subtle glow of these eyes, reflecting in the Cambrian waters, small beacons of awareness in the otherwise quiet, sun-dappled oceans. These innovations laid the foundation for predator-prey interactions, a gentle but profound shaping of ecological relationships. As we visualize this genetic and anatomical revolution, allow your mind to drift with the rhythm of the Cambrian oceans. Picture tiny creatures experimenting with movement and form, gently exploring their surroundings. Visualize DNA acting as an invisible architect, shaping life in subtle, deliberate ways. Every ripple of the water, every sway of a limb, every tiny shadow cast on the seafloor reflects the slow, intricate unfolding of evolution itself, a process both delicate and profound. In this calm exploration, notice the elegance of these early experiments in life's architecture. Each body plan, each appendage, each sensory organ represents a step in the long journey toward complexity, diversity, and the intricate ecosystems we see today. Life is not hurried here. It moves with purpose, guided by the invisible hand of genetics and the steady rhythm of the environment. Chapter 5. The Dance of Life. Predator, Prey, and the Rise of Ecological Interactions. As we drift further into the Cambrian oceans, let your mind follow the gentle currents, tracing the subtle rhythms of an ecosystem awakening complexity. In the previous chapters, we explored the diversity of creatures and the genetic blueprints that shaped their forms. Now, we turn to the interactions that bound them together, the beginnings of predator-prey relationships, and the subtle dance of survival that gave rise to intricate ecosystems. Picture the seabed, soft and sandy in places, interrupted by rocky outcrops and early reef structures. Life is moving in a slow, mesmerizing ballet. Tiny grazers nibble on microbial mats, their bodies swaying gently with each motion. Above them, soft-bodied predators drift silently, their movements deliberate, calculated, yet fluid, like a quiet, graceful current guiding life itself. One of the most iconic predators of this era was Anomalocaris, a creature that has fascinated scientists for centuries. Imagine it gliding effortlessly through the water, its long, segmented body undulating with subtle elegance. Its large, spiny appendages reach forward with a fluid grace, capturing unsuspecting prey. Yet, despite its fearsome reputation, its movements are calm and hypnotic, a mesmerizing example of efficiency and adaptation in motion. Meanwhile, trilobites scuttle across the sandy seabed, their hard shells reflecting dappled sunlight, moving with a quiet determination. Some graze on algae, others burrow into sediment for safety or to find food. Their interactions with predators are subtle. Each movement, each turn is part of a delicate balance between threat and survival. Imagine the soft scuttling of many trilobites, synchronized with a gentle sway of water, creating a rhythm both calming and captivating. Ecological interactions were not limited to predator and prey. Symbiosis and competition began to emerge. Some creatures developed protective shells or spines to deter predators, while others evolved speed or camouflage. Filter feeders sifted the water, removing microscopic particles and contributing to the clarity of the oceans, indirectly supporting the survival of other species. Imagine a slow, gentle web of life forming across the Cambrian seabed, each species subtly influencing the other in ways both seen and unseen. The emergence of eyes and sensory organs further enriched these interactions. Simple eyes allowed prey to detect movement, while predators honed their strategies to anticipate escape. The Cambrian seas became a stage for subtle intelligence, where even the smallest actions carried consequences. Visualize the gentle flicker of movement across the ocean floor, the soft shadows cast by grazers and hunters alike, as the silent rhythm of life unfolds in harmony with the environment. Reef structures and sediment layers created microhabitats, allowing for diverse ecological niches. Some creatures clung to reefs for shelter, while others moved freely in the open water. Currents carried larvae across vast distances, seeding new communities and fostering even greater diversity. Imagine drifting along with these currents, feeling the gentle motion of water guiding life through the complex tapestry of ecosystems. Even in this delicate balance, innovation thrived. Creatures experimented with appendages, body shapes, and feeding strategies, leading to an explosion of functional diversity. Some burrowed for protection, some developed filtering mechanisms, and others learned to glide or swim with fluid, mesmerizing grace. Each adaptation was a subtle negotiation with the environment, a calm and deliberate response to the challenges of survival. From a scientific perspective, these ecological interactions were foundational. Predator-prey dynamics encouraged rapid evolutionary experimentation, while symbiotic relationships strengthened resilience and stability. The Cambrian Explosion was not merely a period of new species, it was the dawn of ecosystems, where life began to understand its place in the larger web of existence. As you visualize this ancient ocean world, notice the calming rhythm of the interactions. A predator gliding through the water, a prey gently burrowing for protection, tiny grazers exploring the sand in quiet synchronization. Hear the imagined soundscape. The subtle scraping of limbs, the slow undulation of bodies through the currents, the faint whisper of water moving over reefs, creating a tranquil, immersive meditation on life's earliest ecological complexity. Even though these interactions involve survival and predation, they are not chaotic or violent in this vision. Instead, they form a slow, purposeful dance, a delicate balance of motion and stillness, tension and release, teaching us that even the earliest life moved with rhythm, elegance, and harmony. In this serene exploration, allow yourself to drift with the currents, observing the gentle ballet of the Cambrian seas. Every interaction, every movement is part of a larger story of life experimenting, adapting, and flourishing. The oceans hum with potential, with complexity, and with a quiet yet profound energy that continues to resonate through the ages. Chapter 6: The First Underwater Cities, Cambrian Reef Ecosystems. As we drift along the gentle currents of the Cambrian seas, allow your imagination to linger on the structures that shaped the underwater world. Life, while still young in its complexity, was beginning to create its first architectural wonders, reefs, mounds, and colonies that would serve as both shelter and foundation for countless creatures. Picture a vast, shallow ocean floor bathed in soft sunlight, where the sand is interrupted by delicate towers and mounds formed by microbial mats, early sponges, and other tiny builders. These early reef-like structures were modest compared to the coral reefs we know today, yet they were teeming with life. Imagine gliding over these underwater gardens, noticing the gentle sway of organisms anchored to the seafloor, each contributing to the slow construction of a living city. These reefs provided more than mere shelter. They created a framework for ecological diversity. Small grazers navigated the labyrinthine surfaces, finding food and avoiding predators. Tiny filter feeders clung to the structures, filtering nutrients from the gentle currents. Predators, in turn, explored every nook and cranny, their movements deliberate and mesmerizing. Visualize the intricate dance of life across these reef surfaces, a calm choreography where every organism has its role and rhythm. The materials of construction were remarkable in their simplicity and elegance. Microbial mats, colonies of bacteria that thrived on minerals in the water, formed layered surfaces. Sponges and other sessile animals added verticality, creating small towers and mounds. Even the exoskeletons and discarded shells of early creatures contributed, creating complex surfaces and textures. As you drift above these formations, notice the interplay of colours and forms, the pale greens of microbial mats, the subtle translucence of sponges, and the soft glimmer of tiny shells reflecting the sunlight. Reef ecosystems also encourage behavioural innovation. Some animals developed burrowing habits to exploit the soft sediment between structures, while others evolved appendages designed for clinging, climbing, or probing the nooks of these miniature cities. Observe the subtle strategies of survival unfolding here. The quiet scraping of limbs against the reef, the gentle probing of sensory appendages, and the measured glide of predators between shelter and open water. These early reefs were dynamic, ever-changing habitats. Storms or shifts in currents could reshape surfaces, subtly altering the landscape. Organisms adapted, recolonized, or moved to more favorable spots. Imagine the gentle reshaping of this underwater world, where even small changes in the environment ripple through the ecosystem like a soft, deliberate pulse. From a scientific perspective, the development of these reef ecosystems marked a pivotal moment. They provided stable habitats for an increasing diversity of life forms, fostering ecological specialization. Early reefs were hotbeds of innovation. They concentrated nutrients, offered protection, and allowed creatures to interact in increasingly complex ways. Life was learning to build, to organize, and to create spaces for experimentation, a lesson in patience, resilience, and harmony. The reefs also served as visual and sensory marvels in this underwater realm. Imagine drifting past clusters of spiny trilobites navigating the surfaces, translucent worms undulating through the spaces between, and tiny filter feeders swaying with the currents. Each organism adds motion and texture, creating a mesmerizing mosaic of life that calms the mind as you observe its slow, deliberate beauty. Even more subtle interactions occurred among the reef builders themselves. Microbial mats and sponges competed for space and resources, shaping the very architecture of the reef. Layers accumulated gradually, each organism leaving its imprint in sand, sediment, or calcium deposits. Imagine the quiet layering of time, the slow accumulation of life-building structure upon structure, revealing the hidden artistry of evolution in motion. These early architectural ecosystems remind us that life is not only about survival, it is also about innovation, collaboration, and the creation of beauty. The Cambrian reefs were the first cities of life, intricate, interconnected, and full of purpose. They demonstrate that even in the earliest chapters of Earth's history, life was capable of remarkable creativity, patience, and adaptation. As you visualize this calm, ancient world, allow yourself to drift along the reef surfaces, noticing the soft sway of appendages, the quiet scraping of grazers, and the gentle glide of predators. Hear the imagined symphony of life, the subtle movement of water over structures, the faint rustle of limbs against sediment, the soft hum of currents carrying nutrients across this miniature city. Let the complexity and harmony of these reefs soothe your mind, a meditation on the slow, patient unfolding of life's architecture. Chapter 7. Sensing the World. The emergence of eyes and early vision. As we glide above the calm sunlit waters of the Cambrian seas, let us pause to consider a subtle yet profound transformation, the evolution of sensory perception. Life, previously confined to simple touch and chemical awareness, was beginning to see the world in new ways. Eyes, the windows to the environment, were opening for the first time in a vast array of forms, forever changing the rhythm of the oceans. Imagine a small, soft-bodied creature drifting near the ocean floor. Its body is delicate, almost translucent, and it senses the movement of water and the presence of chemicals around it. Slowly, a cluster of light-sensitive cells emerges, a simple eye spot. It can detect the difference between light and dark, a gentle guide that helps the organism navigate its surroundings. Though primitive, this innovation allows a subtle awareness of danger, of shadow, of the presence of other creatures. Picture this quiet awakening, a soft glow of perception illuminating an otherwise unseen world. Over generations, these simple eyes evolved into more sophisticated structures. Compound eyes appeared, made up of numerous tiny lenses, each capturing a fragment of the environment. Trilobites, with their iconic compound eyes, could now perceive movement, detect predators, and search for prey with remarkable accuracy. Imagine the way sunlight reflects off their multifaceted eyes, each lens capturing a delicate piece of the underwater mosaic. The result is a vision both precise and poetic, as if the creature perceives the world in a quiet kaleidoscope of motion and colour. Eyes were not the only sensory innovations. Antennae, tactile appendages, and delicate hairs evolved to sense currents, vibrations, and chemical cues. Imagine a small predator gliding silently above the seabed, its antennae gently brushing against the water, detecting the presence of prey or the approach of a larger predator. Each sensory input adds a layer of awareness, a soft and continuous connection to the environment. The evolution of vision and sensory systems fundamentally changed ecological interactions. Predators could now stalk with subtle precision, while prey developed strategies for camouflage and evasion. Soft-bodied grazers learned to detect shadows above, burrowing into the sediment or seeking refuge in the crevices of early reefs. Imagine the slow, deliberate dance of perception and reaction unfolding across the Cambrian seascape, a quiet ballet of awareness that guides life with elegance and balance. Consider the Anomalocaris again, the predator of these seas. Its large, forward-facing eyes provide depth perception, allowing it to judge distances with precision. The delicate spines at the front of its body act as sensory organs, detecting even the smallest movement in the surrounding water. Visualize it gliding in silence, eyes scanning every ripple, every shadow, orchestrating its hunting with a calm, measured grace. Even simple creatures benefited from these sensory innovations. Filter feeders and grazers, unable to pursue or evade actively, used light sensitivity and tactile cues to adjust their orientation, optimize feeding, and avoid obstacles. Imagine the subtle awareness they possess, a quiet responsiveness that enhances their survival, as gentle currents carry nutrients and tiny prey particles through the water. From a scientific perspective, the emergence of vision represents a pivotal evolutionary leap. The genetic mechanisms behind eye formation were ancient, but the selective pressures of the Cambrian seas, predation, foraging, and navigation, accelerated their development. Life was learning to interpret the world in new dimensions, transforming both behavior and morphology. Each glance, each detection of light or shadow, contributed to the slow, deliberate choreography of ecosystems. In your mind's eye, drift through this scene of perception and awareness. Picture the glint of compound eyes, the soft flick of antennae, the gentle pulse of sensory hairs brushing against currents. Hear the imagined soundscape, the faint ripple of water disturbed by movement, the soft brushing of tiny appendages against sand, the subtle changes in currents signaling life's activity. Feel the rhythm of awareness, the quiet harmony of perception guiding life across the Cambrian oceans. This innovation, sensing the world visually and tactically, set the stage for more complex interactions, coordinated movements, and the eventual development of behaviors that resemble modern ecosystems. It allowed creatures to respond not randomly, but purposefully, creating a world where life is in constant dialogue with its environment. As you drift with the currents and observe these early sensory marvels, notice the calm elegance of a world awakening to itself. Life is learning to perceive, to react, to navigate with awareness and balance. The Cambrian seas are alive not only with movement but with perception, a subtle, harmonious symphony that invites contemplation and serene reflection. Chapter 8. Beneath the surface, the first burrowers and hidden life. As we glide gently above the Cambrian seabed, allow your mind to wander downward, past the sunlit waters and colourful reef structures, to the soft sandy sediments below. Here lies a hidden world, quiet and deliberate, where life explores a new dimension, beneath the surface. The first burrowers, small yet remarkably innovative, were carving tunnels and creating a subterranean ecosystem that would forever change the dynamics of the ocean floor. Imagine a delicate creature, soft-bodied and flexible, probing the sediment with tiny appendages. It begins to dig a shallow tunnel, slowly displacing grains of sand. The movement is calm, almost meditative, a subtle interaction with the environment. These early burrowers were not merely seeking shelter, they were exploring a new way of life, a hidden space in which to feed, hide, and interact. Picture the intricate network of tunnels forming beneath the seafloor, like quiet veins pulsing through the sand, creating microhabitats for countless organisms. Burrowing offered many advantages. It provided protection from predators gliding above, shielding soft bodies from the occasional strike or shadow. It also gave access to nutrients deeper in the sediment, particles that would otherwise remain out of reach. Imagine the calm precision of these creatures, each movement carefully displacing sediment, each tunnel forming a new pathway through the quiet ocean floor. Some burrowers left traces behind, intricate patterns that would become the first fossils of behavioral activity. These trace fossils, known as ichnofossils, reveal slow, deliberate motion, the gentle scraping of appendages, the sinuous curves of a body navigating the sediment, the small depressions marking a pause to feed. Visualize these traces as a silent story etched into the seafloor, a meditation on persistence, patience, and the hidden rhythm of life. Life beneath the sand was not solitary. Burrows could intersect, creating networks of shelter and foraging paths. Some organisms may have even engaged in subtle symbiosis, sharing spaces or following the trails of others to find food. Imagine a labyrinth of tunnels, each occupied by creatures moving in harmony with the sediment, each responding to vibrations and chemical cues in a slow, measured dialogue with the environment. The emergence of burrowing also changed the physical structure of the seabed. Sediment was continuously disturbed, aerated, and enriched, creating a dynamic habitat for microorganisms. These microbial communities in turn supported small grazers and filter feeders, establishing the foundation of a complex underground ecosystem. Picture the soft textures of sand layers, subtly reshaped by the continuous activity of these tiny architects, forming a quiet, ever-changing landscape beneath the ocean's surface. Predators above the seafloor influenced this hidden world as well. The subtle presence of hunting and Anomalocaris or other early predators encouraged cautious behavior, driving the evolution of more complex burrowing strategies. Some tunnels extended deeper, with multiple entrances and exits, while others were lined with hardened sediment or secreted materials to provide stability. Visualize these tiny homes as delicate fortresses, built with patience and ingenuity in the soft, sunlit sands of the Cambrian Ocean. The genetic innovations that shaped body plans, explored in earlier chapters, played a critical role in enabling burrowing. Flexible bodies, specialized appendages, and sensory adaptations allowed creatures to navigate the three-dimensional environment beneath the surface. Imagine the delicate coordination required, the soft contraction of muscles, the gentle movement of limbs, the subtle sensing of nearby currents, all orchestrated in calm, purposeful motion. From a scientific perspective, the first burrowers had profound effects on the ecosystem. By reworking the sediment, they enhanced nutrient cycling, increased oxygen penetration, and created habitats that supported even more diversity. Their quiet activity amplified the complexity of life on the ocean floor, establishing ecological principles that would endure for millions of years. As you visualize this hidden world, imagine floating slowly above the sediment, observing the subtle patterns of tunnels and trails etched into the sand. Picture the gentle gliding of burrowers, the quiet rhythm of their movements, the interplay of shadows and light over the undulating sea floor. Hear the imagined soundscape, the soft shifting of sand, the faint brushing of bodies against sediment, the muted pulse of currents above. creating a deeply relaxing and immersive meditation on life beneath the surface. The Cambrian seabed was alive both above and below, a harmonious combination of visible and hidden life. Burrows remind us that even in the quietest spaces, life is active, purposeful, and intricately connected. Their slow, deliberate excavation is a calming testament to the patience, resilience, and innovation that define the earliest chapters of life on Earth. Chapter 9: Breath of Life: Oxygen and the Chemistry of Cambrian Seas. As we drift once again through the sunlit Cambrian waters, allow yourself to feel the subtle rhythm of the oceans, moving with gentle currents and soft waves. Beneath the serene surface lies a silent but essential force, one that made the Cambrian Explosion possible: oxygen. The chemistry of the seas was slowly changing, and with it the possibilities for life expanded in ways that were both profound and transformative. Imagine oxygen molecules diffusing into the water, invisible and unassuming, yet vital for every organism with a body capable of movement. Before the Cambrian period, oxygen levels were lower, limiting the size and complexity of animals. But as levels increased, even slightly, life found new energy. It could grow larger, move more actively, and develop more intricate body plans. Visualize the water enriched with this life-giving element, permeating every nook of the seabed, every reef, and every burrow. The subtle rise in oxygen also had an invisible effect on metabolism. Creatures were able to convert energy from food more efficiently, powering muscles for movement, appendages for feeding, and sensory organs for awareness. Imagine a small predator gliding effortlessly through the currents, its movements smooth, controlled, and purposeful, possible only because oxygen flowed through its tissues, quietly fueling every action. Chemical changes extended beyond oxygen alone. Elements such as calcium, silica, and phosphorus became more available in the oceans, enabling the formation of hard parts, shells, exoskeletons, and spines. Picture a trilobite crawling across the seafloor, its segmented exoskeleton glinting in the dappled light. This shell is not merely protective. It is a product of the subtle chemistry of the water, a quiet collaboration between the earth and life itself. Each mineral particle incorporated into its body tells a story of balance, adaptation, and opportunity. Nutrient distribution was also crucial. Gentle currents and ocean mixing carried dissolved elements and microscopic food particles across the seas. Filter feeders swayed gracefully, capturing nutrients from the flow, while grazers moved over microbial mats, delicately scraping them for sustenance. Visualize the slow, rhythmic motion of these creatures, synchronized with the invisible movement of chemical energy and nutrients in the water, creating a harmonious cycle of life. Oxygen levels influence behavior as well. Animals could explore, burrow, and escape predators more efficiently. Predators, in turn, could become more agile, pursuing prey with a fluid grace previously impossible. Picture the Anomalocaris gliding with subtle undulations, its spiny appendages poised to detect the faintest shadow, its body moving effortlessly through oxygen-rich waters. The invisible presence of oxygen allows this performance to unfold with calm elegance, a dance of life in slow motion. Geochemical shifts also created microenvironments that encouraged diversification. Some areas of the seafloor had slightly higher oxygen concentrations, supporting larger and more active animals. Other regions had richer sediments with more nutrients, promoting specialized feeding behaviors. Imagine floating above the seabed, observing these subtle variations, sensing how life adapted delicately to every change, every chemical nuance. From a scientific perspective, the Cambrian Explosion was not just a story of genetics or morphology. It was a story of environment, energy, and chemistry working in quiet concert. Oxygen, minerals and nutrients created conditions that made complex life feasible, allowing evolution to explore new strategies for survival and interaction. Each rise in oxygen, each chemical change, was a gentle nudge guiding the trajectory of life toward diversity and complexity. Even small fluctuations mattered. A slight increase in oxygen could trigger larger body size, more active locomotion, or more sophisticated predation. Minor changes in mineral availability could allow the evolution of stronger shells or sharper spines. Life in the Cambrian seas responded with remarkable subtlety, adapting with patience, resilience, and quiet ingenuity. As you visualize this invisible but powerful element flowing through the oceans, feel the calming pulse of the Cambrian waters. Imagine oxygen as a gentle breath, circulating through every creature, nourishing life and enabling it to explore, grow, and interact. See the reefs, burrows, and swimming animals responding to these chemical gifts, their movements synchronized with the quiet energy that sustains the oceans. In this serene vision, notice the interconnectedness of all things: chemistry shaping biology, oxygen enabling movement, nutrients supporting diversity, and life, in turn, shaping the sediment and reefs. The Cambrian seas are alive not only with motion and perception, but with the invisible forces of chemistry, a harmonious network that quietly nurtures complexity and balance. Chapter 10: Armor of Life: The Origin and Evolution of Shells and Exoskeletons. As we drift once again through the Cambrian oceans, allow your mind to settle into the rhythm of the water, the gentle sway of currents carrying both life and energy. Beneath this calm surface lies a transformation of form, an evolutionary innovation that would shape the trajectory of life for hundreds of millions of years. The development of shells and exoskeletons. Picture the ocean floor, soft and sandy in places, interrupted by the first reef structures and microbial mounds. Among the creatures navigating this environment, subtle changes are taking place at the microscopic level. Early organisms begin to incorporate minerals from seawater into their bodies, producing the first hard parts. Calcium carbonate, silica, and other elements slowly accumulate, forming protective layers over soft tissues. Imagine the delicate glimmer of these early shells catching sunlight as the creatures move gracefully through the water. These shells and exoskeletons served multiple purposes. Protection from predators was the most obvious benefit. Imagine a trilobite scuttling along the sand, its segmented exoskeleton reflecting light, offering both armor and support. The presence of hard parts allowed animals to explore open water and venture into new habitats without the constant threat of predation. Each shell is a quiet testament to life's ingenuity, a combination of chemistry, genetics, and environmental opportunity. Exoskeletons also enabled more complex movement. Limbs and appendages could be supported by rigid structures, allowing precise locomotion and manipulation. Visualize a small predator navigating through a reef, its exoskeleton providing stability as it twists and turns to capture prey. The combination of flexibility and rigidity created a harmony of movement, a quiet dance of efficiency and grace across the ocean floor. The evolution of shells also influenced sensory perception and behavior. Hard surfaces provided attachment points for sensory hairs and spines, enhancing awareness of the environment. Some creatures developed elaborate spines not only for defense, but as tools for interaction, display, or stabilization in the currents. Imagine the gentle sway of these spines in the water, moving in harmony with the rhythms of life, adding both protection and subtle elegance to the creatures that bear them. Shells and exoskeletons also left a lasting record of life. Their mineralized composition allowed them to fossilize more readily than soft tissues, providing scientists with a window into the Cambrian world. Imagine tracing the ridges of a trilobite fossil, noticing the tiny segments and patterns that tell a story of form, function, and adaptation. Each fossil is a whisper from the past, a quiet meditation on the slow and deliberate innovations of life. The variety of hard parts was extraordinary. Some shells were smooth and streamlined, ideal for gliding over the sediment. Others were spiny or segmented, offering protection and flexibility. Some exoskeletons incorporated intricate patterns, both functional and decorative, hinting at early experimentation with form and aesthetics. Picture this diversity as a calm, flowing mosaic across the Cambrian seabed, each creature contributing to the visual and functional richness of the ecosystem. The emergence of hard parts also reshaped ecological interactions. Predators evolved strategies to penetrate shells or exploit weaknesses, while prey adapted with thicker, more complex armor. This evolutionary dialogue created a dynamic, measured push and pull, enhancing both diversity and complexity. Imagine the subtle tension in the water, a predator gliding silently toward a prey, both guided by centuries of adaptation and innovation, their movements calm, purposeful, and deliberate. From a scientific perspective, the evolution of shells and exoskeletons represents one of the most important innovations in animal history. It allowed life to expand into new environments, explore new behaviors, and develop intricate relationships with other organisms. Without these protective and supportive structures, the vibrant diversity of the Cambrian seas would have been impossible. As you visualize this world, imagine gliding slowly above the seabed, observing creatures of all shapes and sizes, their shells and exoskeletons catching the soft sunlight, each movement synchronized with the rhythm of the water. Hear the imagined soundscape, the gentle scraping of limbs over shells, the soft brushing of spines in the currents, the muted glide of predators navigating the seafloor. Feel the harmony of protection and motion, a calm and meditative reflection on life's ingenuity. The Cambrian seas were a world of delicate balance, innovation, and quiet exploration. Each shell, each segment, each spine tells a story of patience, resilience, and the slow unfolding of life's potential. The oceans hum with life, both visible and hidden, connected by evolution's invisible hand, and sustained by the calm rhythms of the environment itself. Chapter 11. Hunters of the Deep. The Rise of Predatory Strategies. As we drift gently through the sun-dappled Cambrian seas, allow yourself to follow the slow, purposeful movements of the first predators. The oceans, once dominated by grazers and filter feeders, were now a stage for a new kind of life. Creatures that sought, pursued, and captured others. The emergence of predation reshaped ecosystems, driving innovation, adaptation, and a quiet rhythm of survival that would resonate for millions of years. Imagine a soft, undulating predator gliding just above the sandy seabed. Its body moves with elegant, measured waves, powered by newly efficient muscles fueled by the increasing oxygen in the water. Forward-facing eyes, compound and multifaceted, scan the surroundings with subtle awareness, detecting the smallest movement or shadow. Its spiny, grasping appendages extend gently, ready to capture prey. Though it is a hunter, its motions are calm and deliberate, almost meditative, as if the ocean itself guides its dance. Predatory strategies varied greatly. Some predators relied on ambush, remaining motionless until unsuspecting prey wandered near, then striking with precise fluid motion. Others were active hunters, Patrolling the reef or open seabed with rhythmic grace, their sensory systems finely attuned to chemical signals, vibrations, and visual cues. Imagine drifting alongside these hunters, observing the balance between patience and precision, between stillness and motion in a choreography as old as life itself. The prey species responded in kind. Grazers, burrowers, and filter feeders developed defensive adaptations. Thicker shells, spines, rapid burrowing behaviors, or subtle camouflage. Visualize a small trilobite scuttling over the sand, its segmented exoskeleton glinting in the light, aware of shadows above. A delicate antenna senses vibrations, and it suddenly dives into a burrow, disappearing from view. The predator pauses, recalibrates, and continues its exploration. A quiet interaction of awareness, patience, and adaptation. These predator-prey interactions were not chaotic. They were a harmonious rhythm, a gentle push and pull that structured the Cambrian ecosystems. Predators guided the movement and behavior of prey, which in turn shaped the evolution of hunting strategies. Over millions of years, this dynamic fostered innovation and complexity, each subtle interaction adding depth to the unfolding tapestry of life. The most iconic predator of this era, Anomalocaris, exemplifies this balance. Its large, compound eyes provided precise spatial awareness, while its flexible, segmented body allowed for fluid, controlled motion. Its grasping appendages, lined with spines, could manipulate and capture prey with surprising delicacy. Imagine it moving through the water, scanning the seafloor, pausing and adjusting its position with a grace that mirrors the ebb and flow of gentle currents. Every movement is purposeful yet calming, a meditation in motion. Even smaller predators contributed to this intricate dance. Tiny worms and early arthropods evolved subtle hunting behaviors, using speed, stealth, and sensory awareness to capture smaller prey or scavenge efficiently. Their quiet, persistent activity shaped the sediment, influenced microbial communities, and created microhabitats for others. Imagine gliding over a bustling microcosm, observing countless small hunts, each subtle, precise, and quietly mesmerizing. Predatory behaviors also encouraged diversification in body plans and sensory systems. Predators needed speed, flexibility, and keen senses, while prey required protection, camouflage, and the ability to sense danger. This subtle evolutionary dialogue drove the rapid emergence of new forms and strategies, creating the dazzling diversity characteristic of the Cambrian Explosion. Imagine observing the ocean in slow motion, where each predator-prey encounter is a careful negotiation, a calm and deliberate interaction shaping life in profound ways. From a scientific perspective, the development of predatory strategies marks a turning point in Earth's history. Energy flow through ecosystems became more dynamic, behaviors more complex, and the pressure for adaptation more consistent. Predation was not violent chaos. It was an elegant driver of innovation, a quiet pulse that guided life toward complexity and resilience. As you drift above the Cambrian seabed, visualize the fluidity of these interactions. Watch a predator glide with gentle precision, sense the shadow of prey responding, and notice the subtle ripple of currents disturbed by each movement. Hear the imagined soundscape, the soft brush of appendages over sediment, the faint rush of water displaced by motion, the quiet whispers of a world in balance. Let the calm rhythm of hunting and evasion guide your mind into serene reflection. The Cambrian seas were alive not only with motion but with strategy, perception, and the quiet ingenuity of life learning to interact with itself. Every hunt, every evasive maneuver, every subtle adaptation adds to a symphony of balance. a meditative reminder that life's complexity arises through careful, patient exploration. Chapter 12. Web of Life. The Cambrian Food Chain and Ecological Hierarchies. As we continue our gentle drift through the Cambrian seas, allow yourself to absorb the calm rhythm of this ancient ocean, where currents move slowly and life pulses with subtle intention. Beneath the soft waves, an intricate network is forming, one that will define relationships, survival, and energy flow for millions of years. This is the Cambrian food web, a delicate hierarchy connecting every organism, from the tiniest grazers to the most formidable predators. Imagine the seabed as a complex tapestry of interwoven rolls. Tiny microbial mats cover patches of sand, shimmering faintly under sunlight that filters through shallow waters. These mats are not merely decoration. They are the foundation of the food web, feeding small grazers and filter feeders. Visualize minuscule animals moving across these mats, scraping, grazing, and filtering, each movement slow, deliberate, and harmonious. Their activity supports not only themselves, but also the larger ecosystem, creating a quiet pulse of energy flowing through the seafloor. Above them, small predators navigate the reefs and open waters. Their hunting strategies are precise and measured, relying on keen senses and subtle observation. Picture a small arthropod, its legs brushing lightly against sand grains, sensing the vibrations of a distant prey. Every movement is calculated, flowing in tandem with the soft sway of water, creating a mesmerizing rhythm of pursuit and evasion. Larger predators, like Anomalocaris, patrol the midwater with effortless grace. They glide above the reefs and burrows, scanning with compound eyes, adjusting speed and angle with fluid motions. Their energy consumption, behaviors, and presence influence all levels of the food web below. Visualize the interaction as a calm orchestration, where each predator and prey moves with intent, yet in quiet balance, shaping the ecosystem without chaos. Scavengers also play a subtle but essential role. Imagine the slow, deliberate movement of small organisms over the seabed, consuming detritus, discarded shells, or decaying matter. Their activity recycles nutrients, enhancing the sediment and sustaining microbial communities. Visualize this recycling as a gentle, continuous motion, a quiet undercurrent of life that nourishes the web without drawing attention to itself. Even within the microbial layer, interactions are profound. Bacteria metabolize minerals and organic material, creating chemical gradients that influence behavior, reproduction, and movement of larger organisms. Picture these invisible processes as a soft, underlying pulse, a calm rhythm that guides life on the surface and within the sediment. Life, at all scales, is connected through subtle flows of energy and nutrients. The food web establishes hierarchies that define ecological niches. Grazers and filter feeders dominate the base, predators occupy higher levels, and top predators patrol the open waters. Each layer depends on the others, and the health of the system relies on this delicate balance. Imagine floating above a reef, observing the soft, synchronized dance, grazers moving methodically, predators gliding in arcs above, and scavengers quietly tracing the substrate. There is order, there is flow, and there is calm. Predation, competition, and symbiosis drive innovation in form and function. Hard shells, spines, burrowing behaviors, and sensory adaptations all evolve in response to pressures from multiple levels of the food web. Each subtle adjustment, whether thicker armor, faster movement, or improved camouflage, echoes across the ecosystem, shaping the next generation of life with quiet precision. Visualize this process as a slow, deliberate evolution of strategies, each change harmonizing with the overall rhythm of life. Even at a microscopic level, chemical interactions shape the web. Nutrient availability, oxygen levels, and mineral composition influence growth, metabolism, and distribution of organisms. Imagine these chemical currents as a gentle undercurrent beneath the visible motion, quietly orchestrating the rise of complexity and diversity across the Cambrian seas. From a scientific perspective, the establishment of the Cambrian food web represents one of the most profound ecological shifts in Earth's history. Energy flow became structured, behaviors became interconnected, and ecosystems gained resilience. The hierarchy of life introduced stability and feedback loops, where success at one level influenced all others. It is a testament to the intricate balance of adaptation, innovation, and cooperation across time. As you drift above this interconnected world, visualize the full complexity of the Cambrian food web. Watch the slow, rhythmic motion of grazers across microbial mats, the measured glide of predators through midwater, the quiet recycling of nutrients by scavengers, and the unseen chemical currents that nourish all life. Hear the imagined soundscape, the subtle rustle of limbs over sediment, the gentle brush of predators moving through water, the soft pulse of energy flowing through every organism. Allow this calm harmony to fill your mind, a meditation on the balance and elegance of early ecosystems. The Cambrian food web reminds us that life thrives through connection. Every organism, every behavior, every chemical reaction contributes to a greater network of balance and sustenance. It is a quiet, patient story of interaction and interdependence, a symphony of life that unfolds gently, harmoniously, and endlessly. Chapter 13. Building Blocks of Life, Segmentation and Complexity in the Cambrian. As we continue our gentle drift through the Cambrian seas, let your attention settle on the structure of life itself. Beneath the calm currents and shimmering reefs lies a subtle but profound innovation: body segmentation. This quiet architectural change in animal design would set the stage for unprecedented diversity, specialization, and coordination in the oceans. Imagine a trilobite slowly moving across the seafloor. Its body is divided into distinct segments, each with a specific role and function. The head, or cephalon, houses sensory organs and feeding appendages. The thorax segments allow flexibility and movement. The tail, or pygidium, provides stability and balance. Notice the rhythm of motion as each segment flexes in coordination, creating an effortless glide across the substrate. Segmentation allows both strength and adaptability, a calm yet purposeful choreography of form and function. Segmentation provided evolutionary advantages that were both subtle and transformative. By dividing the body into repeated units, organisms could specialize parts for feeding, locomotion, defense, or sensory perception. Imagine the quiet efficiency of an arthropod using thoracic segments to propel itself while simultaneously coordinating its appendages to grasp or manipulate food. This division of labor within a single body is a meditation on functional harmony, an elegant solution that life discovered quietly and efficiently. Consider also the role of segmentation in growth and repair. New segments could be added as the organism matured, allowing for gradual and controlled development. Damaged segments could sometimes be regenerated or adapted, a subtle yet profound resilience embedded in the body plan. Visualize this slow, measured process, a testament to the patience and ingenuity of life. Segmentation also paved the way for complex appendages and locomotion. Limbs could evolve in a modular fashion, with each segment contributing to the overall movement. Walking, crawling, swimming, or grasping became more precise and coordinated. Imagine a small Cambrian arthropod navigating the reefs, each leg moving in sequence, antennae sensing the environment, and the body flexing in perfect harmony with the rhythm of the water. There is grace, efficiency, and quiet intelligence in every movement. This innovation extended beyond arthropods. Early worms, mollusks, and other soft-bodied animals experimented with repeated body units to improve flexibility, coordination, and survival. Even the arrangement of muscles and nerves became more organized, allowing better communication between segments. Visualize this internal architecture as a hidden scaffold, quietly supporting every motion and interaction. A calming meditation on the harmony of biological design. The evolutionary consequences were profound. Segmentation enabled the Cambrian Explosion to unfold with remarkable speed and diversity. With modular body plans, life could explore countless variations: longer limbs, specialized feeding appendages, defensive spines, and sensory organs. Imagine the subtle ripple of innovation across the ocean floor, each new body plan quietly testing the possibilities, each adaptation building on the last. From a scientific perspective, segmentation also illustrates a fundamental principle of life. Modularity and repetition allow complexity to emerge without chaos. Life can experiment, adapt, and refine without disrupting the integrity of the whole. Picture the Cambrian seas as a laboratory of innovation, each organism a calm, deliberate experiment in form and function, shaping the future of life with patience and precision. As you drift above the seabed, observe the interplay of segmented bodies across the reef. Trilobites crawling in rhythm, worms undulating through the sand, and small arthropods flexing coordinated limbs. Each movement is a meditation in balance and design. Hear the imagined soundscape, the soft scraping of segments across sand, the gentle sway of limbs in water, the quiet pulse of coordinated motion. Let this rhythm guide your mind into relaxation, a reflection on the elegance and intelligence inherent in life's design. Segmentation reminds us that complexity arises from subtle, deliberate innovations. Each segment is a building block, a step toward flexibility, coordination, and specialization. The Cambrian seas hum with quiet ingenuity, a testament to the patient unfolding of life's potential, one segment at a time. Chapter 14: Movement and Motion. The rise of a locomotion in Cambrian seas. As we glide once more through the tranquil Cambrian waters, allow your mind to follow the gentle undulations of life beneath the waves. The ocean, bathed in soft sunlight, is alive not only with form and colour but with movement, a slow, purposeful ballet of survival, adaptation, and exploration. One of the most profound innovations of this era was locomotion, the ability for creatures to move with intention, coordination, and grace. Picture a trilobite on the sandy seabed. Each segment of its body flexes in harmony, propelling it forward. Its legs move in a rhythmic sequence, antennae sensing the environment, guiding every step. Movement is not random. It is a quiet negotiation between body structure, environment, and sensory input. Visualize the subtle sway of the water, the gentle currents interacting with the body, enhancing and supporting motion, creating a calm, flowing rhythm across the seafloor. Locomotion took many forms. Crawling, undulating, swimming, and even burrowing became specialized behaviors adapted to survival. Soft-bodied worms undulated their bodies, propelling themselves through sediment with elegant fluidity. Imagine the hypnotic wave of motion, each ripple passing from head to tail in a perfect sequence, moving silently yet effectively through the substrate. Swimming offered new opportunities for exploration and interaction. Creatures like anomalocarids glided through the water with lateral fins, their bodies flexing in controlled motions. Every movement is purposeful, a combination of speed, precision, and efficiency. Visualize this predator scanning the midwater, adjusting its trajectory with subtle shifts, each glide measured and smooth, a quiet meditation on motion itself. Crawling and walking along the seabed also became more coordinated. Limbs evolved in modular segments, allowing precise articulation. Small predators or scavengers could manipulate the substrate, navigate obstacles, and pursue prey efficiently. Imagine observing dozens of creatures moving across a reef in synchrony with currents, a harmonious choreography of life that flows without haste, yet full of intent and subtle energy. Burrowing animals added another layer to the movement landscape. Their soft, segmented bodies contracted rhythmically, displacing sediment with calm, deliberate precision. Visualize tunnels forming beneath the seabed, pathways extending in quiet networks, providing shelter, feeding grounds, and microhabitats. The motion is both protective and functional, an undercurrent of life beneath the visible world of swimming and crawling animals. Locomotion also drove interactions. Predators pursued prey with calculated speed, prey adapted evasive maneuvers, and the interplay created a balanced rhythm across the ecosystem. Even subtle movements, like antennae brushing against sediment or body flexing to sense currents, became part of this complex dialogue. Picture these interactions as a slow, deliberate dance, each movement echoing across space and time, a testament to the elegance of evolution. The evolution of movement was supported by changes in musculature, segmentation, and nervous systems. Muscles evolved to contract in coordinated patterns, nerves to transmit signals with precision, and segments to provide flexibility and control. Imagine the interior of these creatures as a quiet network of pulsing energy, orchestrating motion with calm precision, a hidden symphony guiding every glide, crawl, and undulation. Even environmental factors influence locomotion. Currents, sediment density, and water viscosity shaped how animals moved, subtly guiding adaptations. Imagine a small arthropod adjusting its gait to navigate soft sand, or a predator leveraging gentle currents to glide silently toward prey. Life in the Cambrian seas responded with elegance, patience, and quiet intelligence to every challenge the environment presented. From a scientific perspective, the development of locomotion was a turning point in the Cambrian Explosion. Mobility allowed animals to explore new habitats, expand ecological niches, interact with other species, and adapt more rapidly. The ocean became a three-dimensional stage for life, filled with motion, interaction, and a balance of energy that shaped evolution in profound ways. As you drift above the seabed and through the open waters, visualize the full spectrum of motion. Trilobites crawling with segmented grace, worms undulating rhythmically through sediment, predators gliding silently above, and burrowers weaving tunnels below. Hear the imagined soundscape, the soft brush of legs across sand, the gentle ripple of water displaced by swimming bodies, the subtle undulation of soft-bodied creatures in their burrows. Allow this slow, purposeful rhythm to calm your mind, a meditation on the harmony of motion and the elegance of early life. Locomotion reminds us that life is not merely present, it is active, responsive, and deeply connected to its environment. Every glide, crawl, and undulation is part of a quiet symphony of adaptation, a gentle unfolding of potential across the Cambrian seas. Chapter 15. Sensing the World, the Dawn of Perception in Cambrian Seas. As we continue to drift slowly through the tranquil Cambrian waters, allow yourself to notice the subtle pulse of life, the quiet energy flowing through every reef, burrow, and open stretch of sand. The Cambrian seas were not only alive with motion and structure, they were beginning to hum with perception. Animals were learning to sense the world, to detect subtle cues in their environment, and to interact in increasingly sophisticated ways. This chapter explores the emergence of sensory-driven behaviours, a quiet revolution that added a new dimension to life. Imagine a small arthropod crawling over the seafloor. Its antennae sweep gently, brushing the fine grains of sediment. These delicate sensory organs detect vibrations, chemical gradients, and even tiny changes in water flow. With each movement, the creature gathers information about nearby predators, prey, or obstacles. The motion is slow, deliberate, and precise, a meditation in awareness, reflecting the first stirrings of perception in animal life. Vision also began to evolve in remarkable ways. Compound eyes, as seen in creatures like trilobites and anomalocaurids, provided a mosaic of images, giving the ability to detect movement, light, and shadow with extraordinary sensitivity. Picture a predator gliding above the reef, scanning with multifaceted eyes, detecting the faintest ripple of movement below. Each visual cue informs its motion, guiding it with calm precision toward prey, while also alerting it to potential threats. Chemical sensing, another subtle yet vital sense, allowed animals to detect food sources, mates, or predators from a distance. Tiny sensory hairs or specialized organs picked up dissolved molecules in the water, creating an invisible map of the environment. Imagine a filter feeder pausing in mid-current, antennae quivering as it detects a faint chemical signature of nutrients nearby. Its motion adjusts, a gentle shift toward sustenance, harmonized with the rhythm of the surrounding water. Touch and mechanoreception were equally important. Animals could feel vibrations in the sediment or currents in the water, providing vital information for both hunting and avoiding danger. Picture a trilobite pausing as it senses a subtle pressure change beneath the sand, a predator moving above. It reacts with a controlled, deliberate motion, retreating into a burrow or adjusting its path, a quiet example of survival guided by perception. Even simple sensory interactions shaped behavior. Small worms, grazers, and early arthropods responded to the presence of others, either by moving toward food or avoiding competition. Symbiotic and social behaviors began to emerge, driven by these sensory cues. Imagine a community of creatures across the reef, each attuned to the presence of others, moving in subtle coordination, creating a calm, balanced network of interaction. The evolution of sensory systems also influenced predation strategies. Predators became more effective hunters, capable of detecting hidden or camouflaged prey, while prey evolved behaviors and defenses to evade detection. This subtle dance of perception and response created a dynamic yet measured balance in the ecosystem. Visualize this interaction as a slow-motion ballet, each movement guided by awareness, each response deliberate, each interaction harmonious with the rhythms of the sea. From a scientific perspective, the emergence of sensory-driven behaviors marked a pivotal moment in the Cambrian Explosion. Life was no longer passive. It could perceive, respond, and interact with its environment in increasingly sophisticated ways. Sensory innovations drove behavior, shaped morphology, and facilitated new ecological roles, allowing organisms to explore, exploit, and coexist in complex habitats. Consider also the role of the environment. Light penetration, water clarity, and substrate type influenced how senses evolved. In shallow, sunlit waters, vision and color perception became increasingly valuable. In deeper or murkier regions, chemical and mechanosensory systems were more critical. Imagine drifting through different zones of the Cambrian Ocean. observing how life subtly adjusts to the sensory challenges of each environment, a quiet reflection of adaptability and balance. As you float above the reef and sea floor, visualize the intricate interplay of perception and motion. Trilobites sensing shadows, predators scanning mid-water, worms responding to chemical gradients, and burrowers detecting vibrations beneath the sand. Hear the imagined soundscape, the soft brushing of sensory hairs, the gentle ripple of water currents, the faint vibration of sediment under movement. Allow these subtle cues to guide your imagination into relaxation, a meditation on awareness, perception, and the quiet intelligence of life. The Cambrian seas remind us that life is not only shaped by form or motion, but by perception, by the quiet ability to sense, respond, and interact. Every subtle detection, every gentle adjustment, contributes to a harmonious and balanced ecosystem, a serene testament to the intelligence embedded in the earliest animals. Chapter 16. Life Renewed. Reproduction and Early Life Cycles in the Cambrian. As we glide gently through the Cambrian seas, allow yourself to feel the subtle rhythm of renewal that flows through these ancient waters. Beneath the sun-dappled surface, life is not only moving, hunting and sensing, it is also reproducing. The Cambrian period marked a quiet but profound innovation, the development of more complex reproductive strategies and life cycles, ensuring the continuity and diversity of life. Imagine a quiet patch of seabed, where small arthropods or worms gather in shallow pools. Many of these creatures release eggs and sperm directly into the water, a gentle dispersal guided by currents. Visualize the tiny eggs floating slowly, carried by subtle ripples, each one a potential spark of life, suspended in the calm rhythm of the ocean. Fertilization occurs almost invisibly, yet with precision, as nature orchestrates these early cycles with patience and subtlety. Some animals developed brooding behaviors, sheltering their young within protective segments or specialized appendages. Picture a trilobite carefully guarding clusters of eggs, the soft glow of sunlight filtering through the water, casting gentle shadows over the protective exoskeleton. This quiet attention to reproduction enhances the survival of offspring, a deliberate and meditative act embedded in the rhythms of life. Larval stages also emerge during this period, allowing offspring to disperse, feed, and grow before reaching adulthood. Imagine microscopic larvae drifting above the seabed, gently carried by currents, feeding on plankton, and slowly developing the structures that will one day support more complex behaviors. Their motion is calm, deliberate, and synchronized with the environment, a quiet reflection of growth and potential. Reproductive strategies were closely tied to environmental cues. Seasonal changes, currents, and nutrient availability influenced when and how animals reproduced. Picture a sunlit reef where the density of life shifts with subtle tides, prompting synchronized spawning events. Thousands of eggs and larvae float in slow, harmonious arcs, a mesmerizing display of patience and balance, each individual a testament to life's resilience. Sexual reproduction during the Cambrian also fostered genetic diversity. By combining genetic material from different individuals, animals increased their ability to adapt to changing conditions, resist predators, and exploit new niches. Imagine this as an invisible, calming undercurrent shaping evolution, guiding life toward innovation without haste. A quiet and deliberate unfolding of potential across generations. Parental care, though rare, began to emerge. Some early arthropods carried eggs under their bodies, while others used specialized pouches or protective structures. Picture a small creature slowly moving across the reef, its young securely tucked beneath a segment or in a tiny chamber. Every step, Every motion is gentle, synchronized with the environment, ensuring that life continues in a quiet, stable, and measured way. The development of reproductive strategies also influenced ecological interactions. Larvae became a food source for small predators, while adults adjusted behavior to protect offspring or maximize reproductive success. These interactions created subtle, layered dynamics within ecosystems, contributing to the overall stability and complexity of the Cambrian seas. Visualize this interplay as a calm, three-dimensional network of life, flowing gently through space and time. From a scientific perspective, the Cambrian reproductive innovations were crucial for the success of complex life. They ensured population continuity, enabled the colonization of new habitats, and facilitated rapid adaptation. Life cycles became more sophisticated, linking movement, sensory perception, and ecological interactions into a cohesive, harmonious system. As you float above the reefs and open seabed, visualize the full spectrum of reproductive life. Eggs drifting with the currents, larvae feeding on microscopic plankton, parents guarding young, and subtle interactions shaping population dynamics. Hear the imagined soundscape, the soft rustle of tiny bodies in the water, the gentle sway of currents carrying eggs and larvae, the quiet rhythm of life unfolding in cycles. Let this calm, measured process guide your mind into relaxation, a meditation on renewal, continuity, and the quiet intelligence of early life. Reproduction in the Cambrian seas reminds us that life is not only about survival in the moment, but also about ensuring the future. Every egg, every larva, every protective behavior is a step in the patient, deliberate unfolding of life's story, a serene testament to resilience, adaptation, and the quiet rhythms of existence. Chapter 17. The Pulse of the Seas, Environmental Influence on Cambrian Life. As we glide gently through the Cambrian oceans, let your mind drift with the subtle rhythms of the environment, the quiet interplay of water, light, and temperature that shapes life in profound yet serene ways. The Cambrian seas were not static. They were dynamic systems, gently sculpted by currents, tidal forces, and sunlight, creating the conditions that allowed biodiversity to flourish. Understanding these environmental influences offers a calm insight into the balance of early life. Imagine a shallow reef, sunlight filtering through the water in dappled patterns, illuminating the sand and the reefs in gentle warmth. The angle and intensity of light influenced behavior and survival. Photosensitive organisms like early arthropods or worms responded to these variations, adjusting their movement, feeding, and reproductive patterns. Visualize tiny animals pausing in the soft glow, sensing the change in light, moving slowly in harmony with the environment, a quiet meditation on adaptation. Temperature gradients also played a subtle but critical role. Different parts of the ocean had varying warmth, influenced by sunlight penetration, depth, and currents. These gradients determined where species could thrive, shaping the distribution of life. Imagine warm, sunlit shallows bustling with grazers and predators, while cooler, deeper zones host slower-moving or soft-bodied organisms. Life adjusted gently, each species finding its rhythm and comfort zone, creating a natural mosaic of diversity across the Cambrian seas. Currents provided both movement and connection. Gentle flows carried plankton, nutrients, and larvae across vast distances, linking distant habitats and facilitating ecological interactions. Picture microscopic eggs drifting with the currents, slowly settling into new environments, or tiny plankton feeding in the subtle eddies of water. The motion is calm, deliberate, and essential, a hidden force shaping life in quiet, continuous ways. Oxygen availability also influenced diversity and distribution. Areas with slightly higher oxygen supported more active predators, whereas lower oxygen zones hosted slower, sedentary species. Visualize a layered ocean, where life adjusts to subtle chemical gradients, each organism finding its place in a delicate balance, the pulse of survival synchronized with the flow of the water and the availability of resources. Turbidity, or the clarity of water, affected feeding and sensory behaviors. Clear waters allowed predators to hunt visually, while murkier zones favored chemical sensing and mechanoreception. Imagine a predator gliding smoothly through clear water, its compound eyes scanning for movement, while another predator in slightly turbid waters relies on subtle vibrations in the sediment. The environment dictates the method, and life responds with calm precision, creating a diverse array of behaviors and strategies. Seasonal and tidal fluctuations added another layer of rhythm. Even subtle changes in sea level, current strength, or sediment movement influenced the timing of feeding, reproduction, and migration. Picture synchronized spawning events triggered by subtle shifts in temperature or tidal flow, thousands of tiny eggs drifting in gentle arcs, a serene choreography orchestrated by the environment itself. The interplay of these factors, light, temperature, currents, oxygen, and turbidity, created a rich tapestry of habitats. Reefs, open sands, deeper basins, and shallow tidal zones each hosted unique communities. Visualize floating slowly above this complex mosaic, watching life adjust, move, and interact with the subtle cues of its environment. The scene is quiet, measured, and harmonious, a meditation on adaptation and resilience. From a scientific perspective, environmental factors are a fundamental driver of biodiversity. They create constraints and opportunities, guide evolutionary paths, and establish the rhythm of ecosystems. In the Cambrian seas, life responded not with haste, but with patient adaptation, tuning behaviors, physiology, and interactions to the subtle pulse of the world around it. As you drift above the Cambrian seafloor, imagine sensing these subtle environmental cues yourself. The warmth of sunlight on the water, the gentle flow of currents, the faint shift in temperature, the soft glow illuminating the seabed. Observe how life moves in harmony with these rhythms, grazers adjusting their pace, predators timing their strikes, larvae drifting with the currents, and entire communities finding their place within the environmental mosaic. Hear the imagined soundscape, the soft rush of water, the gentle ripple of currents, the faint shifting of sand, and the calm, continuous hum of life responding to its surroundings. The Cambrian seas remind us that life is deeply intertwined with the environment. Every motion, every behavior, every adaptation is guided by the subtle pulse of the world, the rhythm of light, temperature, and water. By understanding this harmony, we see life not as random, but as a patient, deliberate unfolding in response to the gentle forces of nature. Chapter 18. The Architecture of Early Reefs, Foundations of Marine Ecosystems. As we float deeper into the Cambrian seas, let us shift our gaze toward one of the most remarkable achievements of early marine life, the creation of reefs. These weren't the vast coral kingdoms we know today, but they were the first attempts by life to build lasting communal structures, stone-like fortresses crafted not by accident, but by cooperation between organisms and the environment. Close your eyes and picture the seabed of 500 million years ago. The water is warm, shallow, and filled with light that penetrates all the way to the sandy floor. In these places, life found an opportunity, not just to survive individually, but to build together, creating habitats that would shape the destiny of marine ecosystems for millions of years to come. Unlike the colourful corals of modern oceans, Cambrian reefs were constructed mainly by archaeochiathids, strange sponge-like organisms with porous conical skeletons made of calcium carbonate. They looked like tiny stone cups, rooted in the sediment, often clustering together. Some were solitary, while others grew side by side, their walls touching, forming the beginnings of reef-like mounds. Imagine diving into this ancient sea. The archaeochiathids stand upright like miniature stone towers, water flowing gently through their porous walls as they filter out tiny food particles. Around them, microbial mats of cyanobacteria grow in thin, slimy films, trapping sediments and stabilizing the reef. Together, these organisms created the first true architectural communities of Earth, structures that did not just host themselves, but provided shelter, food, and opportunities for countless other species. The reefs became bustling microcosms. Tiny trilobites scuttled across their surfaces, finding both food and safety in the crevices. Small worms tunneled in the sediments beneath, leaving winding tracks. Brachiopods, the shell-like filter feeders, anchored themselves nearby, waving their feeding structures into the current. Now imagine hovering gently above such a reef, life teeming at every scale. Microscopic plankton drift by in the sunlit water, settling briefly on archaeochiathid walls before being swept away by the current. A predator approaches, perhaps an early arthropod, with spiny legs and compound eyes, and hides behind the reef's ridges, waiting for prey to pass. Each niche, each shaded corner, each current-facing wall of the reef provided new opportunities for survival. The reef was not simply a structure, it was a foundation for biodiversity, a living city where species interacted, competed, and coexisted. The stability of these reefs depended on delicate environmental conditions. Warm, shallow seas provided abundant sunlight and stable temperatures. Gentle currents carried nutrients without disturbing the fragile builders. The chemistry of seawater, rich in calcium carbonate, allowed archaeochiathids to secrete their stony skeletons. But these conditions were never permanent. Shifts in sea level, changes in water chemistry, or bursts of sediment could damage or bury reefs. This fragility teaches us something profound. Ecosystems thrive when balance is maintained, yet they can unravel quickly when conditions shift. Though archaeochiathids were the main architects, they did not build alone. They relied on cyanobacteria and microbial mats to cement sediments, on currents to bring food, and on surrounding species to occupy the spaces they created. In this sense, Cambrian reefs were early experiments in ecological cooperation, an understanding that survival often requires partnership, not just competition. This principle is timeless. Even today, modern coral reefs host thousands of species that rely on one another, fish cleaning parasites from larger fish, algae providing food for corals, predators keeping populations balanced. The roots of such cooperation trace back to these Cambrian pioneers. For roughly 40 million years, archaeochiathid reefs flourished across the shallow seas of the world. They became the dominant ecosystem engineers of their age, spreading from continent to continent as tectonic plates shifted and seas opened. But like many experiments in Earth's history, their reign was temporary. Environmental changes, possibly linked to cooling climates or chemical shifts in the oceans, led to their decline by the end of the Cambrian. By then, however, they had left a permanent mark on evolution. Reefs would return in new forms, first with other sponges, later with corals, mollusks, and algae. Each new generation of builders inherited the principle first pioneered by the archaeochiathids, that life can shape its environment into something enduring, something greater than the sum of its parts. As you drift above the imagined Cambrian reef, let your breathing slow to match the calm rhythm of the currents. Picture yourself gliding weightlessly, observing the stone-like towers below, life bustling yet peaceful in their shadows. Hear the faint rush of water moving through porous walls, the soft stirring of sand as trilobites crawl, the gentle suspension of plankton in the sunlit haze. These reefs, though long vanished, carry a lesson for us, that cooperation, balance, and patience can build worlds that last far beyond the lives of individuals. From a modern scientific lens, Cambrian reefs represent one of the first large-scale ecological frameworks. They demonstrate how life moves beyond survival to construction, reshaping the environment and enabling greater diversity. They also remind us that ecosystems are fragile, deeply dependent on stability in climate and chemistry. When we look at modern coral reefs, with their dazzling biodiversity, we see echoes of those ancient beginnings. They are in essence the great-grandchildren of archaeocathid mounds, living testaments to the enduring principle that life builds upon life. As you rest with these images, feel the serenity of ancient time. Imagine drifting gently, not in a hurry, not bound by urgency, but carried along by the same patient forces that shaped reefs 500 million years ago. You're connected to that history, a witness to life's first grand architectures, the quiet builders of balance and beauty beneath the sea. Chapter 19. The First Hunters. Predation in the Cambrian Seas. Hey guys, as we continue our tranquil journey through the ancient oceans, let us drift slowly into one of the most transformative aspects of life during the Cambrian Explosion, the rise of predators. For the first time in Earth's history, life wasn't only about drifting, grazing, or filtering. It was also about actively seeking, capturing, and consuming other animals. This quiet but profound shift set the stage for much of what we recognize in ecosystems today. Before the Cambrian, life was mostly soft-bodied and passive. Microorganisms and simple multicellular organisms absorbed nutrients directly or grazed gently on microbial mats. But the Cambrian brought an innovation: animals with hard parts, sensory systems, and movement that enabled them to hunt. Imagine the calm sea floor, where trilobites wander slowly, grazing on detritus. Suddenly a shadow passes overhead. A larger creature with grasping appendages moves purposefully, seeking prey. The silence of the ocean is broken not by sound, but by action, one life form pursuing another. This new behavior added tension, balance, and complexity to ecosystems. Life was no longer simply about finding enough to eat. It was about avoiding becoming someone else's meal. The most iconic hunter of the Cambrian was Anomalocaris, whose name means strange shrimp. At up to 1 meter long, it was enormous for its time. Its body was streamlined with flaps along the sides that allowed it to swim gracefully, like a manta ray gliding through the water. At the front, 2 long jointed appendages extended outward, ending in spiny hooks. With these, Anomalocaris could snatch prey and pull it toward its circular mouth, a ring of hard plates that rotated and crushed shells. Picture it moving in slow, deliberate motions, scanning the water with large, compound eyes. When it spotted a trilobite below, it descended with a fluid grace, appendages curling inward like hands reaching for a delicate object. The trilobite struggled but was lifted, rotated and pulled into the predator's mouth. The scene is calm, efficient, and purposeful. Anomalocaris was the first true apex predator, shaping ecosystems by keeping prey populations balanced and driving evolutionary change. While Anomalocaris often steals the spotlight, it was not alone. Many smaller predators contributed to the quiet drama of the seas. Trilobites as predators. Though many were grazers, some trilobites evolved spines, sharp legs, and burrowing behaviours that allowed them to capture small worms or larvae. Imagine one gently flipping over sediment to reveal a hidden worm, then consuming it with calm precision. Wiwaxia and Odontogryphus. These strange creatures grazed with tooth-like structures, scraping surfaces for food, sometimes even feeding on small soft-bodied organisms. Early worms and priapulids. Some Cambrian worms were predators themselves, burrowing beneath the seabed and striking upwards at unsuspecting prey, much like modern ambush predators. Each of these hunters, large or small, played a role in balancing the ecosystem. Together, they created a layered food web, where every niche had both risks and opportunities. Predation sparked a cascade of evolutionary adaptations. Trilobites developed harder exoskeletons, sometimes with spines to deter predators. Burrowing became more common, as small animals hid beneath the sediment for safety. Some evolved faster swimming abilities, using fins or body flaps to dart away from danger. Imagine this dance as a calm, slow-motion ballet. Predator approaches, prey responds, each shaping the other's evolution in a quiet cycle of adaptation. This interaction is sometimes called an evolutionary arms race, though in the Cambrian it was less about speed and more about subtle, gradual change over vast stretches of time. The emergence of hunters fundamentally reshaped ecosystems. Before predation, most life existed in flat layers of microbial mats. With predators patrolling the seas, prey could no longer remain in the open. This encouraged diversification of behaviour, digging, hiding, building shells or growing larger. The seafloor itself began to change. Once smooth and covered with microbial carpets, it became patterned with burrows, trails, and overturned sediment. Life literally reshaped the environment to cope with predators. From a scientific perspective, this shift represents one of the most important drivers of evolution. Predation created selective pressure, ensuring that species had to adapt or perish. It pushed life toward greater complexity, variety, and resilience. Even in this new world of hunters and hunted, the system maintained balance. Predators never consumed all their prey, because the ocean's productivity depended on equilibrium. Every species, whether hunter or hunted, existed within a wider web of connections, each one necessary to the whole. Visualize this balance as a vast, slow-turning wheel. Anomalocaris drifts gracefully above, trilobites scuttle below, worms burrow in shadows, and plankton drift softly in the water column. Every life form plays its part, each adapting in quiet harmony, sustaining the flow of energy through the Cambrian seas. As you drift alongside these predators in your imagination, allow yourself to see not violence, but balance. Hunting and evasion are part of the same cycle, each motion purposeful and measured. The predators are not reckless. They move with precision, conserving energy, acting only when necessary. The prey, in turn, responds calmly with the adaptations gifted by evolution. Listen for the imagined soundtrack, the soft swish of Anomalocaris' fins through water, the faint stirring of trilobites across sediment, the nearly inaudible shift of sand as a worm bursts upward. It is a serene, rhythmic symphony of interaction, reminding us that even predation can exist within a framework of harmony. The rise of predators in the Cambrian Explosion was not merely a story of danger. It was the dawn of ecological balance as we know it. Predators added tension, but also stability, driving prey to diversify and ecosystems to expand. From these early interactions, the principles of food webs, energy flow and adaptation were established, guiding life toward the future we now inhabit. In the stillness of these ancient waters, predation whispers not of chaos, but of order. Every movement, Every adaptation, every interaction has its place in the patient unfolding of life. Chapter 20. Beneath the Surface. Life. Hidden in the seafloor. As we drift deeper into the Cambrian seas, let us turn our attention downward, beneath the rippled sands and soft mud of the ocean floor. At first glance, the seabed might seem quiet and still, a flat surface stretching endlessly beneath the water. But look closer, and you will discover a hidden world, one just as rich and alive as the open waters above. This is the realm of the burrowers, creatures that found safety, food, and opportunity by moving beneath the surface of the earth. Long before the Cambrian, life largely remained upon the surface of microbial mats. These mats were sticky films of cyanobacteria that covered wide areas of the seafloor like a thin, dark carpet. But with the rise of predators during the Cambrian Explosion, remaining exposed became dangerous. Many small organisms began to burrow down into the sediment, tunneling into the soft mud for protection. This simple behavioral shift reshaped the very fabric of the seabed. Imagine a trilobite crawling across the floor, leaving behind delicate tracks on the surface. Nearby, a small worm disappears into the sand, leaving only a faint ripple where it entered. Within seconds, the surface looks empty again, yet beneath it a quiet maze of tunnels and chambers extends outward in all directions. These burrows served many purposes. Some were shelters, safe places to retreat from predators. Others were feeding stations where the animal could lie in wait, sensing vibrations above, and then dart out suddenly to grab passing prey. Still, others acted as filters, with creatures pumping water through their tunnels to extract food particles from the flow. Each burrow became an extension of the animal itself, a home, a feeding tool, and a defense system. Over time, the presence of burrowers changed the very structure of the seafloor. Before, the microbial mats held sediments in smooth layers, preserving delicate textures on the surface. But as more creatures tunneled below, they stirred and mixed these sediments in a process scientists call bioturbation. This mixing released nutrients back into the water, created oxygen channels deeper in the mud, and allowed other organisms to thrive in new ways. What once had been a relatively static environment now became dynamic, constantly reshaped by life itself. It was as if the ocean floor had begun to breathe, inhaling and exhaling through the quiet work of countless tiny engineers. The impact of burrowing went far beyond the creatures themselves. By oxygenating the seafloor, they created opportunities for new species to exist in places that would otherwise have been too hostile. In this way, they acted as ecosystem builders, much like the reef architects we explored earlier. They created hidden habitats where entire microcommunities could flourish. Picture tiny bacteria feeding on organic waste within the tunnels, small worms living inside abandoned burrows, and larvae finding safe places to develop away from predators. The seafloor became a layered world, filled with secret chambers of life, interconnected in subtle ways. Some burrows were temporary, shallow grooves made by creatures moving just beneath the surface. Others were long-lasting, reinforced with mucus, or lined with small particles to create stability. These more permanent structures sometimes lasted long after the animals had moved on, preserved in the geological record as trace fossils. These traces, though left by animals that vanished 500 million years ago, are still visible today, carved into ancient rocks as delicate tubes, spirals and branching tunnels. They serve as silent signatures of life's activity, messages carried forward through time. From a scientific perspective, the development of burrowing behavior during the Cambrian was revolutionary. It not only offered a survival advantage to individuals, but it also transformed ecosystems. By altering sediment chemistry and structure, burrowers influenced the distribution of oxygen, nutrients, and microbial communities. This feedback loop encouraged even greater biodiversity, reinforcing the complexity of Cambrian ecosystems. As we imagine floating above this ancient seabed, it is important to pause and sense the serenity of this hidden world. On the surface, the ocean appears calm, with trilobites wandering slowly and predators drifting in graceful arcs. But beneath, there is a quiet industry unfolding, unseen but constant, with worms, arthropods, and other creatures slowly reshaping the earth beneath their bodies. The soundscape is muted, almost silent, yet filled with subtle vibrations. The faint shifting of sand, the soft collapse of sediment walls, the near imperceptible movements of life digging and building beneath. The burrowers of the Cambrian remind us that sometimes the most profound changes occur quietly, beneath the surface, without fanfare or spectacle. Their patient activity transformed the seafloor from a static layer into a living, breathing environment, one that supported not only themselves but countless others. In this hidden world, we find a reflection of balance, resilience, and the quiet creativity of life.